students, third model. It is about how we have to prove that single irrational number as an irrational number. So here we have taken one example, prove that root 2 is an irrational number. So before that we have to understand a word called co-prime, students. I hope everyone knows that co-primes. Okay, what is meant by co-primes? If any two positive integers have HCF is 1. It means the two numbers doesn't contain, not having any other factor, than 1. Okay, so that means when we take any two numbers, if you factorize it, you must have only one common factor, that is only 1. Then only the two numbers can be said as co-primes. For example, here when you take 2 and 3, if you get the factors of 2, that is having only two factors, and 3, that is 3 once 3, isn't it? Here in these two numbers only common factor is 1, so we can decide that 2 and 3 are co-primes. For example, when you take 2 and 18, so here in these two numbers it is 2 once and it is 2 nines and as well as 3 times. And here in these two we are having other factors than 1. Here 2 is also a common factor for these two, so we can say that 2 and 18 are not co-primes. Okay, so this co-primes definition we are using to prove that the given single irrational number is a irrational number, students. Okay, so for that purpose we are following generally that the given number is not a rational number, so not a irrational number. So let us assume root 2 is a rational number. We are assuming it. Why? Because by the process of contradiction we have to take the opposite statement of what exact fact is, that is root 2 is actually, the fact is root 2 is irrational number, but we are taking its opposite statement, that is its contradiction statement, that is called as root 2 is rational. Okay, so we are defining it. Root 2 is rational, that means root 2 is equals to p by q, where here this is very important statement, students. P and q are co-primes. We are assuming it that both in the rational numbers p and q, we are assuming p and q are co-primes here. That means p and q are not having any common factor than 1. So here in this single irrational number we have to do squaring on both sides for 2 times, students. Here we have to follow squaring on both sides for 2 times. So after assuming it, we have to do that. We have to do the squaring on both sides for this. So do squaring on both sides. We are doing that squaring on both sides, so that we will get that root 2 whole square is equals to p by q whole square, isn't it? So square and root gets cancelled here. The value is 2 equal to p by q whole square, students. That means p square by q square. So here we are just LHS is 2, that means single number, and RHS is a single number, p square by q square. We just interchange the numbers here, 2 and q square. So then we get that q square is equals to p square by 2. So continuation we are following here. Okay, q square is equals to p square by 2. Then what we observe here, 2 is dividing p square. 2 is dividing p square, so that 2 divides p also. For example, if p is 4, p is 4, so 2 divides 4 square, that means 16. Then 2 also divides 4, isn't it? So like that here 2 is dividing whom it is dividing? P square. So 2 divides p also, isn't it? 2 divides p also. So when 2 divides p, what we can conclude here? So then we can say that 2 is a factor of 2 is a factor of p. Then factor of p means nothing but what can you say? P is multiple of 2 only, no? P is equals to 2 times some factor k we are taking. So the here before that we have to assume that statement here. After squaring on both sides, whatever we got the statement, we are assuming it as equation 1. So after getting that statement, once again here p is equals to 2k, we will write down, and then after again once again we have to follow the squaring on both sides. So do squaring on both sides once again, students. So here we are continuing. So I hope you are writing notes, follow it down. And next here, what will you get here? P square equal to 2k whole square. After squaring on both sides, p square is equals to 2k whole square. Then what will you get here? P square equal to 4k square. We are assuming it as equation 2. So equation 2 we are putting in the equation 1 here. This is the equation 1. That means in the place of p square we are going to replace 4k square. So what will you get here? 2 is equals to 4k square by q square. So if you interchange it, what will you get here? Q square is equals to 4k square by 2. Okay, 2 and 2 gets cancelled, and what will you get here? Q square is equals to 2 into k square. So, and again a statement will be created here. K square is equals to q square by 2, and where 2 dividing q square, so we can conclude that 2 divides q also. Here the same statement we are repeating, same concept. 2 dividing q square. So what we can conclude? So 2 divides q also, isn't it? So from this statement and from this statement, what we can say, 2 is dividing p and as well as 2 dividing q. So here 2 is also factor of q. So therefore what we can say here, therefore 2 is common factor, isn't it, students? Common factor of p and q. So what we actually assumed at the beginning we assumed that p and q are co-primes, but what final what we are getting, p and q we assumed that co-primes, but finally we are observing that p and q are having a common factor, that is 2 is the common factor. So we can say that what we can say here, 2 is common factor of p and q means p and q are non-co-primes. So we are getting a contradiction statement at the end. So this contradiction, why we are getting this contradiction is, why it is happening? Contradiction is due to our wrong assumption. Okay, so finally we got to know that the assumption is wrong. Okay, finally we are getting to know that the assumption is wrong. So our assumption wrong means the given statement is true only, no? Therefore root 2 is an irrational. Root 2 is irrational. So this is what the procedure when we get a single irrational number, students. So the proof will be finished by this statement, hence proved. Okay, when we can observe that whenever we get a single irrational number, we have to follow the same contradiction statement by assuming it that the given number is not a rational number, not a irrational number, and it means the given number is a rational number, and we are observing it that the given number is assumed by the p by q, and where p and q are co-primes, it is very important statement. P and Q are co-primes, and then squaring on both sides, and we will get a statement that the 2 is factor of P, and then 2 is a factor of Q also. Then P and 2 is a common factor of P and Q. So we can conclude that the assumption is wrong that the P and Q are co-prime, since they both are having a common factor other than 1. What is it? The common factor is 2. So this contradiction is due to our wrong assumption. So we can conclude that the root 2 is a irrational number. Okay students, this is the end of the all three models in the concept proving irrationality. By this we can conclude that whenever we get a question in the examination, any one model of these three, then we have to clearly practice it well, and definitely there will be a question based on this concept. Most probably we expect a first model, that is somehow difference of two irrational number where we have to follow squaring on both sides, students. I hope you understood this concept, and I just explained one problem for each method or model. So I hope you practice many more questions to become strong in this concept. Okay, if you like my video, please share to your beloved ones, whoever studying class 10th, and or the students who are feeling difficult in this concept. Okay, thank you students, thank you one and all. If you like my video, please watch, subscribe to my channel, and we will definitely learn it together. The channel is all you.